If you're wondering why I'm over here typing away, then that's why. So yeah, you guys should definitely check that out after this talk if you're still around. And yeah, this is the bytes track. So the whole idea with this is like spider bytes and stuff like that. So it's more of an attack sort of track versus the bits over there, which is a little more technical and into kind of non-attack sort of stuff. But anyway, this is Aaron, and I hope you enjoy his presentation.
Thanks, everybody. Thanks for coming out. Welcome. I've got kind of the dueling banjo laptop thing going on here because I can't get display on here, so if my slides don't match what I'm saying, I'm doing them in sync. And so yell at me if that's the case. Test. Can everybody hear me? All right, so we'll just go right into it. Wicrawl, what are we here to talk about today? We're going to talk about a new wireless scanning auditing tool called Wicrawl. And here's the agenda here, who I am, current state of wireless, what Wicrawl is, what it does, how it works, some use cases, examples, screenshots, demo, the whole kind of thing. Also, I have some live CDs of the tool, if I forget to mention it, with Backtrack as well. Who am I? Aaron Peterson. I'm the project manager and a developer for Wicrawl. Founder of Midnight Research Labs, which is a kind of security-based research group based out of the Bay Area. Started about a year ago. There's lots of social groups, social, technical security groups in the Bay Area, but not, very many that are, actually doing things, projects and things like that. So I wanted to start a group. Also the co-founder, consultant with Alpha Defense. Co-founded it with Bill here in the audience. Consultant by day, pen tester at night. Here's a little blurb on MRL, what we do, monthly meetings, projects, etc. And so if you're in the Bay Area, look us up, midnightresearch.com. Here's the current state of wireless. The picture might be a little dramatic, but wireless is everywhere. Access points. Everybody, probably the first thing they did when they got to their hotel was, pull up Kismet, pull up NetStumbler, see how many access points are out there, see what you can connect to, try to get internet, those types of things. And the problem is there's so much wireless that it's really difficult to pull out what we really care about. And that really applies to a lot of different use cases. And we'll talk about all those different use cases and how Wicrawl fits those things in a second. But here it says here, we don't want to have to manually scan through these access points. We don't want to have to try to associate to each one, get an IP, look at really what is in this access point, other than it exists. Again, having Kismet come up and tell you that there's, 50 access points. We got 42 in our hotel last night with no antenna, internal card, and we scanned through them, and only a couple were. That time we just wanted internet access, so only a couple were useful. Especially when you get to large numbers. If you have a big antenna, so some of the pre-background for Wicrawl is I live downtown San Francisco, and I could get access to about 300 plus access points with a very small grid antenna. And I didn't want to have to crawl through all those things, so I wrote a quick Perl script to just iterate through, try to associate, see what was there. And I'm lazy, I just want to hit a button, have it go. So moving forward, what do we know? For wireless, there's a few different. These are the general use cases that are sort of outlined for Wicrawl. We've got the pen testing group, security professionals who really want to, drill down into a given access point, a given, device, see what it really is, see if it's vulnerable, see if it's, connected to your network, those kinds of things. Your IT person are often concerned with access points on their network that aren't supposed to be there, rogue access points. In the last 6 months or a year, everybody's been talking about internal threats, those kinds of things. Well, a rogue access point is, it's a $50 thing. You stick it into your network that completely subverts your security for your entire network. So if somebody installs that, you want to know about it. Getting and staying on the internet, again, that's sort of just like the business traveler. I travel a couple times a month, and I don't want to have to, find access. I just want to have it through. Again, last night there was 42 access points and only a couple of them were useful. Or, you know, the group of people who just wants to search through, you know, look for curiosities, those kinds of things. What's behind that access point? The magical land of Narnia, or the soft, chewy underbelly of my corporate network being exposed. So we want to look through those different types of things. So Wicrawl comes in. What that gives us the ability to do is to have more goal-oriented checks to filter through these different access points based on plugins and profiles, which I'll go on to. And so what that allows us to do is filter down to just the pieces of information that we care about, whether it's, you know, things that we can get onto the internet through, or whether it's a piece of equipment that's on my corporate network, things like that. So what's Wicrawl? It's a little kind of markety blurb there. You know, auditor, flexible, simple, passive discovery, and active crawling. That's actually the most important part of that, is that we can discover all the access points, but we can actively crawl through them to find out what's there. Powers in the plugins. The plugins implement discrete checks for individual things. The examples here, you know, can we associate? Can we DHCP? Can we map the network? You know, checking for proxies, those types of things. One of the cool features I think about Wicrawl is it allows multiple cards and actually run plugins over multiple cards at the same time, so that you can have one card just doing discovery and all the rest of the cards, you know, in parallel plowing through these access points to try and find, you know, the information that we care about. You know, that's different things to different people. We've got a pretty cool GUI. We'll show it. Some extra things like GPS support, text-to-speech, hooks for doing external things, doing an antenna. There's where you can get it. midnightresearch.com/project/Wicrawl. I'll put that up after this speech. There's a few different parts to it: the discovery, the plugin engine, the plugins themselves, profiles, which determines how we run it, and the UI itself. And we'll talk about each one of those. Kind of a generic architecture diagram. Basically just puts all the pieces that I was just talking about into little boxes and puts them here. Not too useful, but the point is we've got a cloud of access points and cards for each one of those things. So let's talk about the discovery engine. Discovery engine by itself is what we have more or less today. Today what we have is Kismet and NetStumbler, and that tells us that an access points exist. It just, you know, looks for these things and finds that. So that's its job. Does passive discovery, obviously requires monitor mode, handles different radio header types, which is actually kind of important for all the different drivers. We can dump the traffic and send that to the plugins so that the plugins have access to look at the information that we've been capturing, and then talks to the plugin engine through IPC. It's written by Jason Spence, the man in the red hat right here. So here's the architecture overview here. We've, you know, it starts from libpepcap, we pull it apart, and it goes to the hyperpimp, patented trademark name there, and then flows up through IPC into the plugin engine. Plugin engine itself, basically it takes all the information that we get from the discovery engine and schedules all the other pieces that we need. For example, the cards that we want to connect, the plugins that they want to run, and the access points that we want to talk to. And the profile, which we'll talk about, determines all those types of things. It'll turn on and off the discovery engine as needed. We'll talk about how through the plugin engine. SSID filtering, which is important, so we don't scan access points that we are not supposed to be. So plugins themselves. The plugins are, I would say, the most important part of Wicrawl, because that's where the functionality itself is implemented. And a plugin can be anything that you want it to be. It's a pretty simple interface. It's really easy to write these things. We've got about, I don't know, 15 or 20 plugins right now. The plugin engine calls these by passing parameters and things to the environment. And the plugin itself can be any type of executable, you know, a binary written C, or we've got a lot of Perl and Bash ones, or for the fashionable programmers there, Ruby and Python, things like that. we've got a couple templates in the directory that you can take a look at. And if you're interested in writing one, I suggest it's really simple. You can just add a few lines to this template for calling, nmap, for example, or Nessus, or things like that, and have it automatically run when you want it to in the correct order for these given access points. Another important thing, I think, is that for these plugins, a lot of really cool tools for wireless that do individual things. For example, AirCrack, I think, works pretty well. AirCrack NG now. However, some of these tools, not AirCrack, is a little difficult to make and build, and maybe a little bit more difficult to use. Meaning, with AirCrack, if you want to, if you use it well, you have to sort of start several things by yourself, sort of manually. And I think it's kind of annoying, because I find myself doing the exact same things over and over again, which is a good case for automation. For example, you have to start dumping, and then you want to start doing error replay to try and inject, known ARP packets, and then we want to try and crack it. There's all these threads that run that you manually have to set up. Well, our AirCrack plugin does all those things for you. You just schedule that plugin, and it starts the dumping, the injection, and starts cracking that through the plugin interface. Some more things. I'll try not to get too boring with this, but the workflow for Wicrawl is when it's running the plugins, it has these event levels that it tries to escalate through. Again, we have various levels of access to an access point. The very first level is we know that it exists. The second level is we can actually associate it to it. Now, there's many different things that you have to do to try to associate to it, or it can be many things. For example, maybe all you do is associate directly to it. It's really easy and fast. Or you might need to actually crack web or WPA or these types of things to be able to get to on there. Once that happens, you move to the next event level. In this case, we're associated, and then what we want to try to do is get an IP address. Now, that might just mean running DHCP in a large number of cases. Well, it also might mean trying to grab an IP address that's already on that network, or a number of other things, another number of other ways to get an IP address. So you run through these plugins, in order of, what you think is most likely to get you an IP address until you escalate to the next event level. There's 4 basic ones for the scheduled plugins, and we'll talk about what that means. And then there's also some for the hooks, and we'll talk about hooks in a minute, but we can schedule things pre and post discovery and pre and post action. Each plugin can have multiple event levels, such that, for example, there's a text-to-speech plugin that announces things, so that you can associate the text-to-speech plugin to have internet and have IP. So if you're, say, a business traveler, and you just want to hit a button and lay down until Wicrawl says, Wicrawl found internet access through access point WeFoo, or something like that. You can just hit the button, let it go until it announces. Anyway, the point is that there's hooks there to trigger these external things. Another good use case is GPS. You want it to trigger right when it happens rather than to be scheduled. Or if you're moving an antenna, you want to record the antenna position right away. Run lengths. They are different plugins will take shorter or longer to run depending on what they are. For example, in the new AP, new access point, association might take you 3 seconds, where running AirCrack can run an indefinite amount of time depending on how many ARP packets and traffic and those types of things. So we don't want to schedule those in the same run. We want to go through all the short ones first, then all the medium ones, and then all the long ones. And then there's run levels. That's basically just the order that they'll run in. So for example, you want to run, again, association first before you run AirCrack, something. So this is the workflow. There's a whole lot of text on this page. I'm not going to read it all back to you, but I just wanted to give you a good idea of how it escalates through these. What this basically covers is how it escalates from one event level to the next. When it gets to a point where it can't go any further, it will schedule all the different access points before it goes to a longer run length of plugin. For example, again, take the IW config versus aircrack example. You don't want to waste all your time on one access point with aircrack when you can be looking at all the other access points first. So you want to make sure and run that, look through all the access points, then go back to those if needed. So then there's actually a plugin replay path, which when you move from a short to a medium run length, it will replay all the plugins that it took to get to this point. So when you want to go back and run a different plugin at that, you replay the association to get your IP, to get on the network to try to do things. So then you just repeat that until you get to the end, which is either the highest event level, and then you run through all the plugins in that event level, or you get stuck at any given place. You just can't get through an access point, something like that. Different types of plugins. I already talked about this, but basically you can schedule plugins so that you can have things like all your access point based plugins, things that are actually checking something on an access point. They'll be scheduled, but whereas a hook, you want that to run immediately after those things happen. For example, moving an antenna. You want to start moving the antenna before discovery. When you do discovery, when you find an access point, you immediately want to record where your antenna is and where you are. And you want to have that you want that to happen immediately. You don't want it to schedule it in the future, otherwise that information is bad. And then you want to announce it, those types of things. So those are the different types of plugins. Plugin interface just talks about how the plugins talk to the plugin engine. You spawn it, you send in arguments, you put in things to the environment. It comes back in one of three ways. Either standard out will give the reporting, human readable type information. The return code tells what it's supposed to, the exit status, so it, whether you're successful at increasing the event level or not. And then it can also talk directly to if you have programmatic data, like say the GPS coordinates, you can send that directly to the plugin engine. Here's some plugin examples. I talked about a lot of these. Associate. It'll check to see if you can get to the internet, how fast, what your latency is. Run Nmap, aircrack. Run Nessus. We have a couple plugins for WebLab and CowPatty to try to brute force in. It'll randomize your MAC address. Again, GPS, text-to-speech. And in the future, again, the power is in the plugins here. So as many plugins as there are, that's how powerful it's going to be. And so we want to continue to add all these different plugins. So the first few are like trying to defeat captive proxies, check for rogue access points. There actually is a plugin for checking for rogue access points. It tries to just check to see if it can get back to a known server and get some known text. If it does, then it announces that. And then there's all the other obvious security tools for pen testing and things. Just a subsection of the other architecture document, a bunch of boxes. This slide is up here really just to show you how easy it is to write a plugin config. You just tell it, I don't know if you can read this, maybe. Just tell it the name, the binary you want to run, some other things about where you want it to run. Again, the run length, event level, those kinds of things. The profiles. This is what tells the plugin engine how and where and when to run. It's the things it manages. For example, again, it manages the cards. So the card scheduling types there are first all, traffic, and signal. First is just start running plugins as soon as I find an access point. All is I want to try to make sure that I can get all the access points I can find with some reasonable certainty that there aren't any more based on some timeout value, and then start running my checks. Traffic just means that you're going to start running plugins on these things in order of how much traffic is on there. So if you are trying to run Webcraft, you're more likely to succeed. Signal is same thing for signal. Profiles also determine what run length. So I'll give you some examples here in a second. Profile examples. the different users or use cases are going to select how they want Wicrawl to run through the profile. So they're going to have different settings for all of these things. A pen tester is going to schedule the all card scheduling, which means, again, you want to look through all the access points that you filter on. Schedule all the plugins, run all the run lengths, those types of things. War driving, you're going to be, moving around in a car, whatever whatever, and so you want to only run the fast ones, the first card scheduling, so look right away. Only the basic plugins, if any plugins at all. Maybe you just want to do discovery. Holding internet access, you probably want to schedule based on signal because you're a little bit more likely to get a good connection through that. Probably only the basic plugins and probably short run lengths. Our UI, I think, is I think it's pretty sexy for a wireless tool. It allows you to configure the plugins and profiles through it. It's themable, so you can run it at night and wherever you're scanning for access points in the night. And it reads all its information from XML files for the different plugins and the access points. So it's easy to replace this UI with, say, a text UI, which we're actually looking for. If anybody wants to help us out with the text UI, that would be pretty cool. It also has a war driving rollup status bar, so that the thought for this is in California, there's a law that any mounted display in your car can only have car data displayed on it, or related to those things. And so you don't want to have just your access points are probably not related to how your car is running. So if you just have a status bar that can tell you how you're doing, that kind of thing. I talked about this. The UI just forks the plugin engine, reads the log file to get sort of what it's doing, but all the actual data is read directly from XML files, so that it's sort of hopefully a pluggable component, so we can have multiple UIs. Here is the UI. You can see a few things right away. We have a few different access points here. They're colored in order of their event level. So the event level for have internet is green, because that's a good, versus we just have the access point is red, and then yellow for somewhere in the middle. Here's the plugin output, so you can see it's drilled down to the given access point, the run that we've done, and then the output for the plugin. This happens to show the association plugin. It was not successful there. Here's the status bar. Again, just kind of a roll-up bar. You can see sort of the ratios of how successful we were, and a easy to read color bar graph there, and also the ratio of encrypted to none. Here's the nighttime theme, similar. Nighttime status bar. So here's the status of this. We're going to have a beta release here. It's the first real release of this. Linux only for now. Probably the next easy targets, I guess, for us are BSD and Mac. I don't know when. We're busy working on the main part of things, so we'll get to that next, I think. There are a few bugs right now. We need to clean up some of the plugins, but it's pretty usable. We'll give a demo here in a minute.
Okay.
The card support needs to be validated here. There's just so many different drivers and so many different cards. It's hard to know what you really support until you test all those plugins. Again, the power's in the plugins. We need, we'd like to develop some more plugins to do some more checks. The UI's done, but like a text UI, I mentioned that. In the future, we have a few things we'd like to be able to do with it. First of all, be able to do multiple computers so that we can maybe cover a whole campus at once in a pen test example, or basically be able to have a cluster of systems together that are all connected and doing intelligent scanning. Multiplexing the access points, that's kind of a 2.0 thing that we'd like to basically be able to associate to multiple access points through the same card, so you can, again, sort of multiplex those things. So you have your, software stack of your 802.11 stack, so you can do this. Plugins, plugins, plugins. Also, info registry, so plugins can send non-related programmatic data back to the plugin engine. Card capabilities. One of the things I found writing this stuff is that there are a lot of different cards who have a lot of different pieces of functionality. For example, the obvious case are some cards can monitor, some can't, or some drivers, I guess. And there are different things. For example, sometimes you can inject through the same interface. This is getting even more complicated with the new Mad Wi-Fi drivers, which actually allow you to have a monitor interface and a station interface at the same time. So you can actually run, this is kind of cool, you can run discovery, continuous discovery through a single card, while at the same time using, again, a virtual AP to run plugins against those access points that you're finding. It's still a little buggy, but it's a cool concept to be able to do that. But obviously not all cards can do that, and so we have to keep track of all those little things, because certain plugins will require certain features. We want to be able to do better reporting, so like in the pen test example, we can have something that looks a little better. Ultra Mega AP Scanning Behemoth, Wi-Fi Distributed Cracking Flash Mob. I don't know. Those are things that I think would be pretty easy to do with Wicrawl, because we can. I mean, we've stuck probably, I don't know, 6 or 8 different cards in just a laptop and running scanning on that. So you can run, again, you have plugins that run in parallel on all of these things, and then just have that sit on top of a cluster that allows you to do either scheduled cracking or other types of distributed cracking against these types of things. It wouldn't be that hard to do on this, plus some other tools for HPC type. There's a bunch of different distributed crackers now. Pretty important slide. I thought about maybe putting this at the front of the talk, but the elephant in the room here is there's a lot of liability for scanning and running these kinds of tools. There's a lot of different use cases here, and you have to be really careful about these days about what you're connecting to, especially if you're doing active active attacks. People draw the lines in different places, and there's some sticky case law examples here of people enforcing at different levels. But if you're in any way unsure, you should just scan your own access points. There's an SSID filter to do exactly that. Use non-invasive profiles when it's appropriate. Again, this is probably obvious to any of the security people in the room, but for pen testers, always get permission. Not only permission, but contracts, insurance, those types of things. It seems like about, I don't know, once every 6 months or so, there's some genius who decides to break into somebody's network or break into somebody's wireless, and after the fact, try to get the company to buy that person's services, or even worse, send them a bill for that. Hey, I've just cracked into your network, give me some money. Well, that's a pretty stupid thing to do if you don't, I'm sure you guys know already, but don't do that. Seriously, don't do that. Especially not with our software. There's a pretty good paper by Sands, how to avoid ethical and legal issues in wireless network discovery. You should read through that. There's, again, this is a very gray area. If you're in any way unsure, only scan your own stuff. Just wanted to say thanks to a bunch of people. Again, Midnight Research Labs, there's a few of us. Jason, who's an engine, Peter, wrote the UI. Focus, who's not here today, helped with the discovery engine. Also thanks to Jason for helping me stay up till like 4 a.m. last night, burning all these CDs and getting demo stuff set up. Obviously, Hikari and Toorcon, thanks. The Backtrack project, we're going to be included in the next Backtrack City, this tool, and another Midnight Research Labs tool called SEAT, Search Engine Assessment Tool, which is going to, I think, kick the pants off of any other tool. We're going to be talking about that next week at Security Opus. So that's going to be included in Backtrack. Security Opus is in San Francisco, the 4th and the 5th of next week. We couldn't do any of these plugins without tools that exist to do these discrete individual checks. Some of the notable things are, Aircrack NG, WepLab and Cowpatty are all pretty good tools. So thanks to those guys, Jennifer Granick, and all you guys for coming out. I guess first, I was wondering if you guys have any questions, and then we also have a demo. Yes? Yes? We've gotten the discovery engine itself to run on the Wort, and the next step is to get the plugin engine to run, and that requires setting up some Perl stuff on there. It's a little bit more work, but we can run the basics of it right now. I don't think it would be too difficult to get the rest of it working on there, but optimally, that's one of the use cases for having a a text UI or even a web-based UI, that kind of thing. Jason was just pointing out, I don't know if you guys could hear that, but basically if we have access to some type of external storage, whether through USB or SD, something like that, we can actually get the Perl stuff to run, but Perl's a little too big to run in the Flash, so right now it's not working without some type of external storage. Anybody else? Go ahead. Yeah, I've had a few people ask me that. The question is, when you're on the train running 30 to 60 miles an hour, is there any way to use this to get consistent internet access? The practical answer is no. The reason is that it just takes too long to associate and connect and try to get access. It will. There is a set of plugins and profiles that will lend itself to doing that, but it's just not fast enough. The Hold Internet plugin will do exactly that. It'll scan and scan and scan until it gets to the internet and stay there connected to that access point, basically until it can't connect to the internet anymore. And then it re-goes back in and starts running discovery and starts over to get to the internet again. I haven't really what I need to do is sit down and calculate how slow you need to be moving in order to make sense to do that, but I have the feeling it's pretty slow. Yeah, maybe walking. Walking around your neighborhood. No, you're going to be routing through completely different networks, and you don't even know it's going to be through and those kinds of things. True. If you have like a a screen session you can attach to, or any other type of IRC proxy or something. The question was, can I make persistent connections across these, and not without external support for whatever you're trying to run is the answer. Anybody else? That's a very good question. We can lead into demo mode. Whoops, there's the questions. This was actually about 2 minutes after war driving through the Jack in the Box drive-through. What's that? That's a boo bucket in the corner, indeed. Um, so, yeah, this is obviously the future. Yeah, the future of Wicrawl. Okay. So, I can't actually see very well what's going on, so I'm going to try to start this up from here. This is Wicrawl. What we're going to have a relatively simple example. First thing to do is set up a filter for exactly the access points that we have here, and then run. I've created a profile specifically for Toorcon just to show the plugins that we want to run, which are some basic set of association things, and then we have a Nessus plugin that's actually going to, assuming that we can associate to our own access points, which works about, I don't know, 75, 80% of the time, we will actually default it just scans the access point, or actually, in this case, the default gateway of what we're trying to run. So we have that. I just right now have the internal card. We pick here which card we want to use for monitor, and then also which card we want to use for plugins. Here's the different set of plugins that we have in this version. You know, a bunch of stuff. And should I kick? I'm going to filter it on ours. Yeah. Only on SSID right now. Yeah, if you're scanning Linksys, I should have installed. I didn't install the text-to-speech stuff. Is dependent on flight, which is kind of fun, but I didn't install that on the system beforehand. Okay, so what's going on now? On the bottom here, you can see it running. You can see it trying to connect. At the top here, you can see the status. We can see the SSID, the different information, the plugin that we're running, and the event level, I guess, that we're at right now. So, what's it say? Should have been a little more selective about my filter, I guess, but we'll see if we can. Yeah, I'm not going to expand the rest of that column there. So what you could see going on there is that it's going from plugin to plugin, and it's trying to run those different plugins against these different access points. We can see in the plugin information here that here's the access point that we have. Here is the here's the plugin set that we've run against it. So we've done the text-to-speech. We've randomized. What's going on here with my little droppy down thing? I'm not sure why it's not dropping down. This is the curse of the demo, I'm certain. Somebody see the... This is weird, we can't see the plugin output. In what you're supposed to see, so under each one of these plugins, there's the plugin output itself. So theoretically, just behind this drop-down box, there's a juicy Nessus scan waiting for us. Okay, I don't know what's going on. I'm going to stop the scanning. You can see all kinds of stuff. I actually have the bottom in debug mode here, or most verbose, I guess. So you can see, you know, each IPC message as we're doing it here. But oh well, that's why. So the Nessus plugin said that it couldn't find the IP address. It tries to look at the local network and find the IP address of what we're trying to connect to. We can. Ooh. should we be dangerous and see what else is out here? Okay. Be responsible here and change back at least to the default plugins, which are the non-invasive plugins. We're just trying to associate and those types of things. I'm going to open up the floodgates for embarrassment, and what I should have done is brought, you know, a giant antenna and. Let's see if we can associate to the Toorcon one here. Does anybody in the room have an idea how many there should be around here? No, I mean, like, you know, have you run Kismet or something and seen, is there a list? Okay. I guess there's like free advertisement here now, I don't know. So it's not running the plugins right now because we continue to find access points. With the scheduling algorithm, I told it all, which means wait for some timeout based on until the last access point that we've found. And it's going to, okay, now it waited some, you know, I think it's 10 or 15 seconds, and now it's continuing to, did it get to the internet through the TC8 one there? Okay, so that's good. We have an access point through, so check internet. Okay, so we were able to get an IP, we were able to associate, get an IP address, but then once we got an IP address, we were unable to get, you know, route out to the network. Sorry? The internet. What? Oh, well, that would. Well, as you can probably guess, I'm pretty sure every single con access point has varying levels of being on the internet. But so for some of you it might work, and some of you it won't. But the answer to the question is, does it say what the failure is? The internet check. This internet check plugin is a very simple one. It tries to ping out to a couple known systems. If it can't get to those systems, then it'll fail. So the failure, if you want a human readable failure message, it should be in the plugin output. So this is just thanks. This is just the output for, you know, the plugin itself after it was run. I would say that the answer is, can the plugin be modified? I think all the plugins we have so far are all either written in Bash or Perl, or are wrappers through other programs that are also written in Bash and Perl. It's all, you can get access to all of those things, but we intentionally made the plugins very transparent so that you can, you know, number one, add your own very easily, but number two, edit the ones that are there. We've been mostly working on the engine so far. We've been mostly working on the engine so far and haven't had as much time to spend on the plugins. So the plugins need a little bit of polish. For example, again, the Rogue AP one should be a little bit more intelligent about checking for whether it's on your corporate network. You know, we've got some other ones like the Cow Patty plugin. If it doesn't find the handshake in the PCAP file that you send it discovery, then it, you know, it won't be able to run. So what we should do instead is dump on that interface until we do find a handshake, and then start breaking. So there's some little things like that in the plugins that need to be, you know, a little bit polished up there. Am I even on the scroll bar here? I can't see anything. Any other questions? Yes? The radio frequency, the channel? I'm sorry, what? The radio frequency range, 335 megahertz. For each channel? I'm not sure what you're saying. Yeah. Yeah, each channel has its own frequency that it runs on associated with it. For each channel. Okay. Anything else? Questions, comments, concerned? How much? Is that the... Yeah. Bids? This isn't like... Yeah, 3 easy payments. Yeah, I'm not getting bids on it like, Johnny Cash and David Maynard. So most of the... Okay, so over here, we should see... well, you can see a few things right now, and it depends on what plugins. But right now, the power is actually, for this card, the power, there's a patch to fix this, but I didn't install it on this system. Will give you good power, and what encryption it is, Latin launch, those types of things. Jason's pointing out that different cards and drivers have different information that's sent back that you can have access to, and you don't always have access to all the information. So certain headers, if you can make your driver give back certain headers, you can get access to all that information. But in this case, with the IPW2200 in this, I don't. So this is the basic information, and probably the important information is here. Oh, you can also, for example, you can save all of the plugin information and those and all of this stuff. I'm not going to do it now because I can't see it, but the point is that you can serialize all this into a report that you can see all of the different plugins that you've run, what the output it is, all the different access points, how far you can get, those types of things. Yeah? Oh, the metric you see there is the completely broken metric. That's actually related to the same problem, the channel and the power in this. It's actually been fixed. The version that I'm going to post today, that leads me into something else. The version I'm going to post the official data to the MidnightResearchLabs.com site today. It's not up there now. We do have some CDs we're going to hand out, but it actually does have that problem fixed. Mm-hmm. So one thing that's weak in every wireless tool right now, in my opinion, is the ability or inability to automatically detect those types of things for the driver and what kind of card, and bring it up and put it in monitor mode and all those kinds of things. We actually take it in and out of monitor mode as needed, but what we don't do is bring up the interfaces automatically. One of the things we want to do in the future is be able to not only detect the card and driver, but what capabilities that has. So all these different drivers have different capabilities that for certain types of plugins, and right now it's pretty flat in terms of what capabilities we expect, but we'd like to be a little bit more intelligent about that. And that leads me to another point about Wicrawl and wireless tools in general, is that if you can't manually associate to an access point, if you can't get into DHCP, there's all kinds of things that can go wrong when you're trying to associate and those types of things. I've had all kinds of version problems, driver problems, and you get into this kind of stuck in the middle no man's land of, why can't I associate? I have an open access point, but I can't, associate, those kinds of things. If you can't do it manually, then chances are Wicrawl isn't going to be able to as well. So that's good and it's bad. It's good because that means that when you can associate to that, when you can get to the internet, it's actually a useful access point. We've found, successfully what's actually useful on that learning, and what's combination of drivers, access point, all these different things can lead to me actually getting on the internet. And in my opinion, that was one of the most annoying things about trying to scan for these things is even though there's an open access point there, it doesn't mean you're going to be able to get an IP address on that, those kinds of things. So I guess that was kind of a long-winded answer, but we hope to be able to detect the card capabilities in the future. And auto. When you start Wicrawl, if your interface isn't up, it won't be able to see it's there. PCAP won't be able to know that, basically. So you have to bring it up first. Anybody else? Does anybody want wares? Go ahead. CD? What's that? Wares? So, yeah. Okay, so number one, what do we have here? And where can we get it in the future? This is a beta version of Backtrack 2. Which you guys probably all know. Backtrack, it's a live CD for doing security. It has all the security tools in one place in a live CD, which is pretty useful and pretty cool. There's a new version that's going to be coming out sometime in the future, not sure exactly when, depending on when they can get around to it. They gave me early access to the beta, and I installed Wicrawl on it and integrated it into the CD. Like I said before, Wicrawl is going to be on the next version of Backtrack along with a couple of our other tools, or one of our other tools. So that's what this is. I'm going to put a torrent up of it, or maybe just a direct download, probably a direct download first of the whole CD, after I give you just the source packages for the tool. So, sorry, the real answer is where can you get it? MidnightResearchLabs.com. And if you look at the projects, Wicrawl is one of those projects. It's /projects/Wicrawl. Unfortunately, I didn't put the source packages on the CD. The tool itself is on there. I should have, but didn't. What's that? All right, guys. Thanks very much for coming out. I appreciate it. Anybody that wants to come on up and get a CD?
Hey, also, if you weren't able to get a badge earlier because we ran out, we have badges now, so you can register. Just want to let you know.
Wow, these are going fast. I have 2 CDs with no cases, and actually I have extra. If anybody wants, I just ran out of CDs. I'm sorry, but I do have stickers and I don't know, cheap pieces of plastic. I haven't. We meet this third Friday. Sorry, I ran out of CDs. Do you have my phone number? Or? Sorry. In San Lorenzo. Oh yeah. It's about 10 miles away. We do actually. We have for MRL we have a general mailing list. I can join. I should actually create a Wicrawl specific list. Huh? What's that? The MRL list is probably the best thing we have right now for that. It's general traffic about our group, which also includes all of our tools. Sorry guys, I ran out of CDs. Yeah. I ran out in like literally 15 seconds.
Testing, sensitivity? Testing. I heard you say hello, but nothing else.
The Jason knows more about the words than I do, but testing. What's that? Oh, they to CTF. Okay, I'll be over in a second. Hey. Before the new Mad Wi-Fi drivers, I was in love with the Proxim cards.
Hello.
The new Mad Wi-Fi drivers are not very stable. There's a lot of issues. They've got this weird, the VAP, the monitor mode interface and the station mode interface. It's cool, but it doesn't work that great yet. I just have lots of problems. Like, for example, when
Testing,
you try
testing.
to-
Hello?
I
Hello?
can adjust the mic sensor. There we go.
Yeah, I can hear
Got
you
two
over
more
here.
hellos.
I think I'll turn it up a little bit. Can you hear me okay?
Are you catching me at all?
Yeah.
What's that?
Oh. How's it go?
Hello?
Yeah, I'll just do that.